session is now working. So the question is, Zach has answered the question. That's good. Okay, let me see if I can. I was trying to show you one more thing here. I'm going to post the solution. There is a little bit theory behind it, and I highly recommend you to read this theory. This theory is when you have a system under damped system, the equation is this one. Let me go back up here a little bit to show you. If I yeah, I showed you this one graphically. Under damped system, there is an equation for each system. If this is under damped system, the equation is given in the book. For critically damped system, it's also given. So I'm going to show you the equation for an under damped system. Okay guys, this is the numerator and denominator. The ratio between the first and the third amplitude is given like this. And I want to show you the remaining solution. Most important is logarithmic decrement. If you see two consecutive cycles, the ratio is this is known as the delta, which is equal to e to the power zeta omega n tau d. And if you have two non-consecutive cycles, like in this case 1 and 3, this is my x1, this is my x3, then how many time periods are there? This is time period 1, this is time period 2. So if you see two time period difference, then the logarithmic decrement is e to the zeta omega n 2 tau d. So if you make a sequence, like if I ask you x1 or xn, the logarithmic decrement would be e to the zeta omega n minus 1 tau d. So this is the important thing. This is what we call the general formula. I would say you could write this down in your notebook. Now, the other formula is for the damping ratio. Once you know the decrement, then you plug it in the damping ratio formula. This formula should also be in your formula sheet. You may see the quizzes questions like this. Okay, guys. The undamped natural frequency is okay. I have a question. This is the symbol. Omega n is the natural frequency without damper, and the relationship between the damped and unnatural is omega d. Okay, guys, and this is the same formula written here. They have written in the hertz form. I have written in the radians per second form. Do you guys understand that? Can you hear me? You know what I'm writing down? Say yes if you have understood this question. Write down yes in the chat box. Have you taken this class before? Engineering dynamics and vibration? So you are familiar what I'm explaining? Can you this is the experiment about a logarithmic decrement, and I'm going to provide you with the data. The data will look like this. You will have to find out the logarithm, all these answers. Okay, let me give you one more problem. This will be your homework. Now we talk. So I want to show you. Oh, 1 second. I have to. Now the simple pendulum. Can you model this? This is your task. So I'm going to share with you a link which you will follow, and the answer is there. But you will practice. If you have any question, you will let me know. Okay. What I'm going to do here. Yeah, this link. This link will help you to model a simple pendulum and find out the damping ratio for that case. Let me share with you this over here. Can you see the screen? Now, if we go here, this is the schematic sketch. This is the picture of the real pendulum. And this is schematic, and this is the free body diagram of a torque. And in this case, this is the mass of the small m is the length, the mass of the link, and big M is the mass of the bob, pendulum bob, and I naught is the mass moment of inertia about position O, ml square over 3 ml square. So then normalizing the acceleration term, and this is our 2 zeta omega n, which is equal to b. In this case, they have written down b. I have used symbol c, but it doesn't matter. You can use up until equation 5. This is all. You see the pendulum, the general equation is theta double dot, and so on. Don't worry about the remaining part, but this data, I'm going to provide you with this data. Yes. So pendulum free response data. You will find out from this figure what is the value of y1, y2, y3, and so on. These are the displacements. Find out zeta from there, and the b is the damping coefficient of this, because you see, let me show you what's happening here. In this case, air acts like a damper, and because of some friction, the data, you will use this data. Can you see the screen, or are you learning what I'm explaining for this lab? So Piru can see the screen. This lab is kind of you have to redo everything, and then you can compare your answers with the answers given. The only thing which you will do, this in this case, this is y1, which is 23.84, y2 is 23.44. You just subtract 2 from y from each y, and do the data by yourself. Or what I will do, I will send you this figure, but the method is same. You know what I mean? Method is same, guys. So I'll provide you with this data. You will find out omega d, zeta, and omega n and b. Don't worry about the remaining part. Validation in the Simulink. We will do the Simulink later stages, but right now you don't have to worry about it. Okay, I have to give you one more thing here. This is another figure. So you can watch this video at home. Okay, I have to stop the video because I'm not feeling well. So is that okay if we just leave it now? Can you finish the lab at home? Okay, bye.